Welcome back. This is going to be the second video in section 5.1. Again, working and using the fundamental identities. Picking up where we left off, going to go into example number 8. So if you're following in your textbook, we're over on page 354. There will be times where we will have algebraic expressions, and it's most appropriate then to use a trigonometric substitution. So you'll notice in example number 8, we are substituting x equals 2 tan theta. They've given us a window between 0 and pi over 2, and then we're actually asked to evaluate, if you will, a radical expression. Similarly, then in the checkpoint, we're asked to use substitution x equals 3 sine theta. So let's work through checkpoint number 8. Again, we've been provided with the definition of x, the substitution here, 3 sine theta, as long as we are between 0 and pi over 2. And we've been asked then to evaluate the square root of 9 minus x squared. Notice in this case, if we were going between 0 and pi over 2, the values of sine theta would be between 0 and positive 1. So we've made that restriction on purpose. We're going to go ahead then and do the direct substitution. So now we have the square root of 9 minus the quantity 3 sine theta squared, still under the radical. We're going to go ahead and simplify the squared, so we have 9 sine squared theta being subtracted from 9, still under the square root. Factoring out the GCF then at 9 leaves us with 1 minus sine squared theta, again still under the radical. Noticing now, 1 minus sine squared theta, we're going to drop back to that Pythagorean substitution. This of course equaling cosine squared theta. So now we have 9 times cosine squared theta. Well, we can separate because we know that the radical of a product is equal to the product of the radicals. So we're going to separate and simplify separately. Then we have 3 cosine theta. This is example number 8, again using a trigonometric expression as an algebraic substitution and simplifying. Last but not least in section 5.1 is another application, this time using logarithmic expressions. We can actually utilize trigonometric values as input. In example number 9 on page 354, you'll notice that they're asking us to write a binomial logarithmic expression as a single log, and we have an addition pattern. So for example number 9, you may recall to condense log expressions, addition turns into multiplication. So again, recalling from earlier in the school year when we were working with logarithmic expressions and equations, we knew that addition would condense to multiplication. So the checkpoint for number 9 suggests that we have the natural log this time, working with the natural log of secant in absolute value, plus the natural log of the sine. Well, again, if we're going to bring these together, we're going to use multiplication. Now we know that there's 2 separate trig values here. Going to take advantage of a reciprocal substitution here, and we know that this is 1 over cosine. And this, of course, is sine over 1. This then is sine x over cosine x. And that reduces then to the natural log of tan. So again, working with the logs, we have a scenario where we have an addition pattern. Addition condenses to multiplication. But we're still, again, as we were in earlier examples, we're still working with two different trig values. So let's see if we can't simplify further. We're going to take the secant and put it in terms of cosine. Remember, we also spoke earlier that wherever possible, in our attempt to simplify, if we can rewrite in terms of sine and cosine only, that gives us the greatest opportunity to simplify. So we leave the sine alone, and we take the reciprocal 1 over cosine for the secant. Multiplying straight across would, of course, then give us the sine x over cosine x. Ultimately, then, the quotient identity, tan x. In both cases, in checkpoint for number 8 and checkpoint for number 9, we're not solving anything. We haven't solved any equations in this section. These have all been expressions. We've been using factoring techniques. We've been rewriting without fractions. We've been using LCD and equivalent fractions in order to simplify, all in an attempt to just uncomplicate the trigonometric expressions. We're going to continue with this discussion in our video 5.2 coming up. But for the 24th of March, the assigned problems come from page 356. Now that we've concluded all the examples for this section, you should be able to go back and do 49 and 50, 53 to 58, and 61 through 64. Again, this assignment needs to be uploaded to me by 9 o'clock this evening by means of a PDF. So if you would, send that forth and I'll be able to take a look at it. Again, coming up, our next video will be more work with trig identities in 5.2.